Wow, that's impressive. Hey, welcome back everyone. My name's Cole, and I got a few more modifications that I want to make on this wood-fired water heater we built in the last video. If you haven't seen that, the link to that will be in the description below. Turns out to be a pretty popular video now, so that makes me really excited. It worked really well. We had a few problems in the last video with drafting, which we also addressed. I went ahead, I did some testing off camera, and it worked. We heated up 300 gallons of water in about 3 hours. The family and I got to enjoy our stock tank hot tub, and the fire burnt really well. However, I was a little disappointed with how slow it was to heat up all that water. In a previous version of a wood-fired water heater, I used about 40 feet of 3/4 inch copper tubing, and it worked really good. Now, the biggest disadvantage I am here is the fact that I tried repurposing that stainless water jacket, and unfortunately, copper is 20 times more thermally conductive than stainless, so I would have to have 20 times more surface area using stainless steel to get a similar heat transfer. So all that means is we got to build a copper heat exchanger. I should have done this off the hop. I was trying to reuse some stuff I already had, and it worked, but we can make it better. So I went ahead, I bought 48 feet of 3/4 inch copper pipe. We're gonna build a really nice heat exchanger, a couple levels, add in a damper or a baffle inside the wood stove. And we're gonna go ahead, miter all the corners. We're not gonna use elbows because that adds a lot to the cost. And we're gonna TIG weld. We're gonna TIG weld copper. We're gonna do all the joints, and that should not have any leaks should this run dry. If we were to use soft solder, if the water ran out of this while the fire was burning, that solder would melt out right away. The other one I built, I did silver solder all of the elbows to the pipe, but that gets a little tricky when you're doing a lot of joints really close together because it tends to create some leaks and different things. So TIG welding is gonna be the coolest and probably the best way of doing that. Once we go ahead and get that copper heat exchanger made, it's why we bolted on the lid. We can just unbolt the lid, pull this stainless one out, we'll put the copper one in, bolt it all back together, and then we're gonna get to some testing. I wanna measure the inlet and the outlet temperature. We'll be able to do some BTU calculations of how much heat we're getting out of our fire and putting into the wood, and then we're gonna see how long it takes to heat 300 gallons of water to hot tub temperature. So I think it'll be pretty fun. We got a few more mods to make, a little bit of different fabricating, TIG welding copper, you don't see that every day, and I think it'll work really well. So with that being said, let's get to work. There we go, we're cutting this one. That didn't take too long to get the old one out. That went pretty well. Let's go ahead. I need to get a bunch of copper cut up. We'll start TIG welding that. Cut out the baffle. This isn't gonna take too long. Okay, well, I got some of the copper prepped and got the welder set up. We're gonna DC TIG this. Now I know welding copper isn't something that you'll hear about every day, but it can be done. It's not all that difficult. And if you're wondering what I'm gonna use for filler wire, I'm hoping that I can just kind of do a fusion weld. Like, this isn't meant to hold high pressure or do anything like that. So as long as it doesn't leak, I'm gonna be happy. But if we do need to add a little filler, we can just use some electrical wire. I got some of this ground wire. I just take the strands out, and it's probably a different grade of copper. But again, I'm not building something structural here. This just needs to be watertight. So it'll work perfect. I've done it before, and let's try and see how this goes. Pretty nice. So I think my plan will be is I'll go ahead and make a bunch of these L's. That way it's a little easier to do one of the joints, and then we can put it together and create our weave pattern. All right, I just marked those holes. Well, I need a hole bigger than the step bit I was gonna use, and so I'm gonna use a hole saw, but unfortunately I have too big of a pilot hole, so I'm gonna show you a trick. Make a sort of a dummy hole in a piece of wood, and then you can come in, clamp it in place, and this acts as your pilot. So that you can use the hole saw. Voila! There we go. I'm going to repurpose some of the fittings off of our other heater. Just going to thread on and then put the top on. Let's go test this thing. I'm going to need to get changed though. The soot, I'm sure I have it all over my face, is just unreal, but it's going to work really good. Okay, I'm going to go turn the water on. Let's leak check this before we bolt the top on. All right. Water's on. Ah, I see one pinhole right there. Any little leak. I can fix that in place, like, thankfully. I don't see any other leaks.
Hindsight, I guess I should have checked that before I put it in, but let's go fix that little leak.
So something I keep forgetting to mention to everyone is we do have a Facebook page now. So if you want to stay in touch with the Centerline Design Shop and see things that don't necessarily make it to YouTube, customers' projects, my own little small projects that I don't feel a need on doing full videos on, you can go ahead, head over to Facebook, Centerline Designs. I'll put the link in the description below, and give us a follow if you want to just stay in touch and see what we're doing. If you've been watching, these are our two bunnies. This is Cashew. She's the more friendly one, and then she has a sister in there that's not too bad either. But they've been working on digging a burrow since they moved outside a couple of months ago, and it's extremely long, and I'm gonna go ahead and measure it. Okay, Acorn. Hey, Acorn. She's not in the tunnel, so I measured it 7 feet quite a while ago and have not checked it. Holy cow. Now I'm pretty sure the tape measure didn't double back on itself. It's fairly rigid and I just kind of fed it in there, but there we are. It is, let's call it 9 feet. It's 10 to here, so it's almost 9 feet of tunnel. Let's give you a perspective. Wow. That is how much tunneling they've done in a couple of months. That's ridiculous. I think it turns a little bit too. Hey, you are busy girls. The top is all buttoned up. It's on. I got not even a full wheelbarrow load of wood, so we'll see how far that gets us. Wood stove's ready to be lit, so let's light it up. I'll get the water flow going, and then once it gets close to a steady state, we'll measure inlet temperature, outlet temperature. We can check the flow rate by filling a 5-gallon pail and seeing how long it takes to do that. Because I believe, knowing the inlet, outlet, and flow rate, you can calculate BTU. So. So I did go ahead and TIG that leak off camera, but you can see that condensation happening already. We're only about 10-15 minutes in. So we're probably about half an hour burning now, and the outlet is starting to come up in temp pretty nicely. And I just want to show you how significant those fire bricks are. I can touch the bottom of the firebox, and it's actually still cold to the touch. Yeah, up there is brutal. Right here, I can still touch. Okay, I've had the thermocouple tied to the inlet water for some time now, just to let it normalize. And it looks like we have about 7.8, 7.9 degrees Celsius incoming, which is 46.5 degrees Fahrenheit. Those numbers should stay fairly consistent because I've been filling the tub for quite a while now, so our whole water system that draws out of the lake will have flushed out any ambient, room temperature water. That's pretty much what we're just gonna consistently have coming in now. So I'm gonna move this thermocouple over to the outlet water temperature going into the tub, and then I'm gonna watch that because this thing's really sensitive. Stoking the fire, having it to reignite will drop that outlet temperature. Fiddling with it in any way really affects it. So I'm going to kind of find the highest value, and then we'll use that to calculate the BTU that we're putting into the water. And I looked it up. That BTU calculation's pretty simple. It's the flow rate in gallons per minute times the exit temperature in Fahrenheit minus the inlet temperature times 504 or something as a 500.4 as a constant. So once I have all the numbers down, we'll do some calculations, and I'm really going to try and use the peak numbers because there's a lot of variables here. Some of the wood I'm using right now is a really dried out spruce, and I don't think it has a lot of BTU or heat value in it. If I used a nice seasoned birch or ash, even a nice pine, would change things a lot again. So yeah, we're just playing around, seeing how things go. So all right, well, I'll get that stuff moved around, and then I'll bring you back in when it's time to check some more temperatures. I also know adding on a section of stovepipe, extending my flue, will help things dramatically too, to really keep that draft going. I just don't have one right now, so that's an easy upgrade to do down the road. All right, here's my crude little setup. I have the thermocouple taped up into the hose a little bit, so that's going to be a perfect reading of our outlet temperature. Okay, there we are, rating 25.8 degrees Celsius or 78.3 degrees Fahrenheit. Now I'm going to turn on min max, and that is going to record our highest and lowest value, and I'm just going to run this through a few refueling cycles, and we'll see what we're at. I guess I could also use the average too. This has an average. Just to give you an idea, I stoked the stove and really tried to improve the airflow over the fire, and this thing just rocketed up to like 96.5 degrees Fahrenheit. Okay, I got the thermocouple unplugged. Let's go ahead and check our flow rate. We need to determine gallons per minute. So I'm going to go ahead, fill up this 5-gallon pail, and then just calculate the gallons per minute on the time it takes. Okay, well, we're getting really close. I'm going to pretty much call that for easy math. I don't think they're 5 gallons right to full either, but that'd be 4 minutes for 5 gallons. So 1.25 gallons a minute. I do have this throttled down to let the temperature rise to prevent as much condensation as I can, but ooh, that's nice and warm. Let's get this back in there. This thing has been just roaring. Wow, that's impressive. Where are we at here? In the 120s, what do we hit? Oh, we hit a high of 140. Wow, that's pretty impressive. If you pay attention to how you put the wood in to really let it just draft, and I think it'll get even better with the flue extension. We are hitting temps of 140 degrees Fahrenheit outlet temperature. So let's go ahead, we'll run that math, and yeah, we're getting close to a hot tub, so better wrap this up. Oh, it's getting windy out. Okay, I went inside and I did some of the calculations. So we had a maximum outlet temperature of 140.4 minus an inlet temperature of 47. And then that gets multiplied by a constant of 500.4 times our gallons per minute of 1.25, and that gives us 58,421 BTUs at that peak value. Now, it obviously doesn't run at peak all the time. Every time you restoke it, it's a ramp back up. So I think average is probably somewhere in about 75% of that, which is pretty good, and I think it'll get better once we extend that flue. That translates to 17.11 kilowatts, which 17 kilowatts, that's a lot of energy. I have a 20 kilowatt boiler in our house, and it doesn't run on all 4 or 5 kilowatt elements. It doesn't run on those all the time. It only runs on usually 2 maybe. So this is more than capable of heating our house, you know, with what it's capturing in the water. So that's pretty cool. That's significant in my books. I think it's way better than the stainless. I don't really have any numbers to compare, but just kind of, you know, feeling it, I can kind of tell it's probably 2 to 3 times better. I knew we weren't going to get 20 times better into the water because you're still dealing with just the water itself being able to absorb that. So Even though copper is 20 times more thermally conductive than stainless, it doesn't mean you're going to get that into the water. And I'm pretty impressed. I learned a lot about this stove and kind of how to burn it with the less is more technique. Once we extend the flue, I think we'll do even better. So I'm going to leave this video there. Thank you so much for watching this little wood-fired water heater series. The first video has become really popular for, you know, typical for me. And I really appreciate everyone watching. So thank you so much. Next video, I'm pretty confident we'll be back on the Snowcat where those tracks are almost ready to put together. And we'll see you in the next one. Cheers.